Fundamentals of Chemistry. Overview. Welcome to Module C of the ATI TEAS 7th Science Series, where we explore the fundamentals of chemistry. In this video, you will learn the structure of atoms and the periodic table, different types of chemical bonds, chemical reactions and their types, states of matter and their properties, solutions, mixtures, acids, and bases, gas laws and chemical energy. Introduction to chemistry. Chemistry is the study of matter and how it interacts, transforms, and changes. What is chemistry? The science that investigates the composition, structure, properties, and changes of matter. Understanding chemistry helps explain how substances interact in the body. Chemistry is essential for understanding medications, nutrition, and physiological processes. This module covers atomic structure, chemical bonds and reactions, states of matter, acids, bases, and pH, energy in chemical reactions, structure of the atom. Atoms are the smallest units of matter that retain the properties of an element. Components of an atom. Protons. Positively charged particles. Located in the nucleus. Determine the element's identity, atomic number. Neutrons. No electrical charge, neutral. Located in the nucleus. Add mass to the atom. Isotopes have different numbers of neutrons. Electrons. Negatively charged particles. Located in orbitals surrounding the nucleus. Involved in chemical bonding. Determine chemical properties. Key concepts. Atoms are mostly empty space. The nucleus contains most of the atom's mass. Electrons occupy energy levels or shells around the nucleus. The periodic table. The periodic table organizes all known elements based on their properties. Organization. Elements are arranged by increasing atomic number. Atomic number equals number of protons in an atom. Groups, columns. Elements in the same group have similar chemical properties. Share the same number of valence, outer, electrons. Example, group 1 elements are all highly reactive metals. Periods, rows. Elements in the same period have the same number of electron shells. Properties change across a period. Categories of elements. Metals, good conductors, malleable, shiny, left side and center. Nonmetals, poor conductors, brittle when solid, right side. Metalloids have properties of both metals and nonmetals along the staircase line. Chemical bonds. Chemical bonds form when atoms share or transfer electrons to achieve stability. Types of chemical bonds. Ionic bonds. Involve transfer of electrons from one atom to another. Form between metals and nonmetals. Create charged ions, cations and anions. Example, sodium chloride, NaCl, table salt. Covalent bonds. Involve sharing of electrons between atoms. Form between nonmetals. Create molecules. Example, water, H2O, oxygen, O2. Hydrogen bonds. Weak attractions between molecules. Important for water properties and DNA structure. Not true bonds but strong intermolecular forces. Example, bonds between water molecules, bonds holding DNA strands together. Chemical reactions. Chemical reactions occur when substances interact to form new substances. Basic concept, reactants products, starting substances transform into new substances. Types of chemical reactions. 1. Synthesis, combination. 2 or more substances combine to form one product. A plus B of. Example, 2H2 plus O2 2H2O. 2. Decomposition. One substance breaks down into two or more products. Of A plus B. Example, 2H2O 2H2 plus O2. 3. Single replacement. One element replaces another in a compound. A plus BCB plus AC. Example, zinc replaces copper in copper sulfate. 4. Double replacement. Two compounds exchange components. A plus CDAD plus CB. Example, acid-base neutralization reactions. 5. Combustion. Substance reacts with oxygen, releasing energy. Fuel plus O2 CO2 plus H2O plus energy. Example, burning wood or gasoline. Conservation of mass. The law of conservation of mass is fundamental to understanding chemical reactions. The law states, matter cannot be created or destroyed in a chemical reaction. Key concept. Mass of reactants equals mass of products. Atoms are rearranged, not created or destroyed. The number of each type of atom must be the same on both sides of a chemical equation. Example, in the reaction 2H2 plus O2 2H2O. For hydrogen atoms and two oxygen atoms on the left. For hydrogen atoms and two oxygen atoms on the right. Mass is conserved. Importance, this principle allows us to balance chemical equations and predict amounts of products formed. States of matter. Matter exists in different physical states depending on temperature and pressure. The 4 states of matter. 1. Solid. Fixed shape and volume. Particles are tightly packed and vibrate in place. Low energy state. Example, ice, rock, metal. 2. Liquid. Fixed volume but takes the shape of its container. Particles are close but can slide past each other. Moderate energy state. Example, water, oil, blood. 3. Gas. No fixed shape or volume. Particles are far apart and move freely. High energy state. Example, air, oxygen, carbon dioxide. 4. Plasma. Ionized gas with very high energy. Atoms lose electrons and become charged. Found in stars, lightning, and fluorescent lights. Most common state of matter in the universe. Properties of matter. Properties of matter help us identify and classify substances. Physical properties. Can be observed without changing the substance's identity. Examples. Color and appearance. Density. Melting and boiling points. Hardness. Conductivity. Chemical properties. Describe how a substance reacts or changes into different substances. Can only be observed during a chemical reaction. Examples. Flammability, ability to burn. Reactivity with acids. Oxidation, rusting. Decomposition. Physical versus chemical changes. Physical change, appearance changes but substance remains the same, ice melting. Chemical change, new substances form, wood burning. Solutions and mixtures. Solutions are homogeneous mixtures where substances are evenly distributed. Solution components. Solvent. The substance that does the dissolving. Usually present in greater amount. Example, water is called the universal solvent. Solute. The substance that gets dissolved. Usually present in lesser amount. Example, salt dissolved in water. Types of mixtures. Homogeneous mixtures, solutions. Uniform composition throughout. Components cannot be visually distinguished. Example, salt water, air, brass. Heterogeneous mixtures. Non-uniform composition. Components can be visually distinguished. Example, sand in water, salad, soil. Concentration. Describes the amount of solute in a given amount of solvent. Can be expressed as percent, molarity, or of acids and bases. Acids and bases are important classes of compounds with opposite properties. Acids. pH less than 7. Taste sour. Release hydrogen ions, H, in water. Turn blue litmus paper red. Examples: vinegar, acetic acid, lemon juice, citric acid, stomach acid, HCl. Bases. pH greater than 7. Taste bitter and feel slippery. Release hydroxide ions, OH, in water. Turn red litmus paper blue. Examples: baking soda, sodium bicarbonate, soap, ammonia. Neutral. pH equals 7. Neither acidic nor basic. Example: pure water. pH scale. Ranges from 0 to 14. 0 to 6, acidic, lower numbers equal stronger acid. 7, neutral. 8 to 14, basic/alkaline, higher numbers equal stronger base. pH in the human body. Maintaining proper pH is critical for human health and survival. Normal blood pH ranges from 7.35 to 7.45. Slightly basic, alkaline. Tightly regulated by the body. Buffer systems. Buffers help maintain stable pH. Neutralize excess acids or bases. Examples: bicarbonate buffer system in blood. pH imbalances. Acidosis. Blood becomes too acidic, pH below 7.35. Causes: kidney disease, diabetes, severe dehydration. Symptoms: confusion, fatigue, rapid breathing. Alkalosis. Blood becomes too basic, pH above 7.45. Causes: hyperventilation, vomiting, certain medications. Symptoms: muscle twitching, nausea, confusion. Importance: even small changes in pH can severely affect enzyme function and cellular processes. Gas laws. Gas laws describe how gases behave under different conditions of pressure, volume, and temperature. Boyle's law describes the pressure-volume relationship. When temperature is constant, pressure increases, volume decreases. Pressure decreases, volume increases. Inverse relationship. Example: squeezing a balloon decreases volume and increases pressure. Charles's law describes the temperature-volume relationship. When pressure is constant, temperature increases, volume increases. Temperature decreases, volume decreases. Direct relationship. Example: hot air balloon rises because heated air expands. Applications in healthcare. Understanding breathing mechanics. Operating ventilators. Oxygen therapy. Understanding altitude effects on the body. Chemical energy. Chemical reactions involve energy changes that can be released or absorbed. Types of energy reactions. Exothermic reactions. Release energy in the form of heat. Products have less energy than reactants. Feel warm or hot to the touch. Examples: combustion, burning wood. Cellular respiration. Neutralization reactions. Endothermic reactions. Absorb energy from surroundings. Products have more energy than reactants. Feel cool or cold to the touch. Examples: photosynthesis. Melting ice. Cold packs, instant ice packs. Energy in living systems. ATP, adenosine triphosphate, is the energy currency of cells. Breaking chemical bonds releases energy for cellular work. Energy transformations follow the laws of thermodynamics. Nuclear chemistry. Nuclear chemistry involves changes in the nucleus of atoms, releasing tremendous amounts of energy. Nuclear fission. Splitting of large atomic nuclei. Releases massive amounts of energy. Used in nuclear power plants and atomic weapons. Example: uranium-235 splitting in reactors. Nuclear fusion. Combining of small atomic nuclei. Releases even more energy than fission. Powers the sun and stars. Example: hydrogen atoms fusing to form helium in the sun. Radioactive decay. Unstable nuclei break down over time. Releases radiation. Types of radiation. Alpha particles least penetrating, stopped by paper. Beta particles moderate penetration, stopped by aluminum. Gamma rays most penetrating, requires lead shielding. Medical applications. Cancer treatment, radiation therapy. Medical imaging, PET scans, X-rays. Sterilization of medical equipment. Summary and key concepts. Let's review the essential chemistry concepts we've covered. Key concepts. Atoms are composed of protons, neutrons, and electrons. The periodic table organizes elements by properties. Chemical bonds, ionic, covalent, hydrogen, hold atoms together. Chemical reactions transform reactants into products while conserving mass. Matter exists in 4 states: solid, liquid, gas, and plasma. Solutions contain solutes dissolved in solvents. Acids and bases have opposite properties measured by pH. The human body maintains pH between 7.35 and 7.45. Gas laws explain pressure-volume-temperature relationships. Chemical reactions either release, exothermic, or absorb, endothermic, energy. Nuclear reactions involve changes in atomic nuclei. Remember, chemistry is the foundation for understanding how substances interact in the body and how medications work. Thank you for watching. You've now gained essential knowledge about chemical principles that underlie all biological processes. Next steps. Review the key chemistry concepts we covered. Move on to Module D, Scientific Reasoning, to learn how to apply the scientific method. Practice relating chemistry concepts to real-world healthcare situations. Your understanding of chemistry will help you excel in healthcare and on your ATI TEAS 7 exam. Keep up the great work!